All right, so as we had stated before, but just saying again, that the graph of a rational function never crosses a vertical asymptote. So it is like I said, it's marking off an x value that we cannot possibly obtain because it causes a it's a discontinuity, but what it causes is a place where we're undefined. The graph of a rational function might cross a horizontal asymptote, but in the long run, what it should be doing is sort of leveling out and approaching that horizontal asymptote for forever. So it's a value that we're slowly going to keep approaching. Like I said, on a small scale, like initially, once you start graphing, you may cross it. Long run, we do not cross it again. So for any rational function, f of that f, which is p over q, where p and q have no common factors other than constants, vertical asymptotes occur at any x value that makes the denominator 0. The x-axis is the horizontal asymptote where the degree of the numerator is less than the degree of the denominator. A horizontal asymptote other than the x-axis occurs when the numerator and the denominator have the same degree. So like I said, just as long as the top and bottom are not sharing common factors, this is how we can quickly find vertical asymptotes and the two kinds of horizontal asymptotes that may occur. So what we're going to do is work on some graphing. So what we're going to do is we're going to initially find real zeros of our denominator. So basically determine the domain of our function. So for practice, I'm going to check the numerator as well, because technically we should always check to see if they share common factors, because otherwise we have zeros there. We're going to find we're finding our vertical asymptotes, then our horizontal asymptotes. Then we're going to find the zeros of the function. So we're going to look for those, what will be your x-intercepts. Then we're going to find your y-intercepts. And then we'll find a couple other values to help kind of flesh out the graphs. We can see what it actually looks like. So this first example is we have 2x over x plus 3. Trying to get my right tool here. So the first thing I'm going to look for is vertical asymptotes. So we can already see that we will not be sharing the same zeros because the top 0 is at 0. So the bottom is 0 when x is equal to -3. So that tells me where one vertical asymptote exists. So we'll have one over here. And actually, I'm going to extend this graph a little bit, because this scale that I gave you is not the best, or this particular set of axes need to be a little taller. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So close to scale here. But like I said, the red line is going to be my vertical asymptote. Now I'm going to get my horizontal asymptote. So that occurs when I'm setting x towards infinity or negative infinity. What we're going to find here is that our leading terms are going to take over. So 2x, and then on the bottom is just going to be x. So we only have one term on top to worry about. We'll have to take the one with the highest power on the bottom. But this, we simplify, it becomes 2. So y equals 2 is my horizontal asymptote. So let's graph that. So we got basically the two confines of my graph. So these are two lines that I shouldn't be, well, the red one definitely should be crossing. The maroon one, I could cross it initially, but long run, I should not be crossing it. So next, we need to find our, what's going to be your x-intercepts, but our roots. So we have to find out where h of x is going to equal 0. So where the bottom equals 0 is undefined. So what I have to really worry about is when is the top going to be equal to 0. So we only look at the top here. So vertical asymptotes, we find the zeros at the bottom. If we're looking for x-intercepts, we look for the zeros of the numerator. But we see that we get one at x equals 0. So automatically, this is going to tell me that's also my y-intercept. Because just a minute, if we were to look for a y-intercept, that is when x is equal to 0. So if we did that, h of 0 will end up being 2 times 0, 0 plus 3, 0 divided by 3, it's just equal to 0. So that 1 point is just that intercept. So I'm going to clear this. What we're going to look for next is a couple points to kind of get a general idea of what this graph is going to look like. So we're going to look for a couple points. So we kind of just want to sort of definitely look on both sides of the vertical asymptote because that's going to be a breaking place where things are going to kind of change. So this is 1, 2, 3. So we're going to look at a point at -4 and a point at -5. So if x was -5, what we get is my function value would be 5. If it was -4, then my function value would be 8. So we're getting a point here at -5, 5, and a point here at -4, 8. Yeah, about there. So one of the things we know is that I should not be crossing that vertical asymptote. So I'm pretty sure I'm doing something like this here. And I should not be crossing this horizontal asymptote, especially as I go out to infinity. So I should be doing something like this. Now we need some points over here. So maybe we'd look at -3. Oh, sorry, -3 is undefined. I meant -2. If I look at -2, I get a function value of -4. And then I got a function value here. So let's look for one over here. So maybe the +3. And that is equal to 1. +3 is 1. So once again, I know I can't cross this, so I just must go along it. I have to cross through 0, 0 here because that was my x-intercept. And then this should go up and follow along that asymptote. So tell me those asymptotes are first, kind of tells me sort of my behavior. So I kind of get there's going to be a little curve here, but I know how the rest of that curve should be going. And if you graph it, this is exactly what this function looks like. So just to show you that was pretty much what we graphed right there in those blue lines. All right, try this one more time. So vertical asymptotes means I need to set that denominator equal to 0. So if we look at the top, we see that the top would be 0 at -3. So as long as one of my zeros in the bottom is not -3, they're going to be asymptotes. So with this one, I'm going to tell you, like, you use AC method, but one of the things I see here is that if I multiplied 2 and 3, that would be -6. So I need factors of -6 that would give me 5. So -6 and plus x. Those ones would work. So that's how I'm going to split that up. So if I do factoring by groups, I can pull out a 2x here, and I'm left with x minus 3 here. Well, the best I can do is pull out a 1, and I'm left with x minus 3. If I factor out my x minus 3, what I'm left with is going to be 2x plus 1. All right. Like I said, and that equals 0. So we would find is that x minus 3 could equal 0, or 2x plus 1 could equal 0. So we see that one of my asymptotes is at 3. and the other one is going to be at -1/2. So these are both of my vertical asymptotes. So 3, and then -1/2 would be right about here. All right, so next would be your horizontal asymptote. So once again, as x is going towards infinity, what we should see here is that f of x should start acting like the leading terms. So it should start acting like x over 2x squared. Well, can be simplified to 1 over 2x. And since x is on the bottom growing bigger and bigger, this fraction is getting smaller and smaller. This is heading towards 0. So I should not be crossing my x-axis at all. So my vertical asymptote would be y0, y equals 0. All right, so let me get rid of some of this, and then we're going to look for x-intercepts and y-intercepts and some additional points. Okay. So like I said, if we're looking for our x-intercepts, also known as our roots or our zeros, that means it's just the top that I have to set equal to 0. And if I do that, we get x is equal to -3. So this means I have a point, second 1, 2, 3, right here, that I'm supposed to cross the x-axis. Now, if I want my y-intercepts, that means I have to look at when x is 0, so I have to look at f of 0. So I have 0 plus 3 over 2 times 0 squared minus 5 times 0 minus 3. So I got 3 over -3, which is -1. So that is where I cross the y-intercept. So now we need just a few additional points to kind of get a general idea of what's going on here. I was trying to check something on here. Get that out of the way. So what we're going to do is we're going to bring up a little chart again. So we're going to look at our x's and figure out what f of x is going to be. So I need a couple other points around this one right here. So let's say this is at -3. Let's look at -2. So at -2, what we're going to get is a 0.07 approximately. So that's just above the line. So maybe we need to take a look at what happens at -1 as well. And we get a 0.5. So that puts me about here. And then because I'm crossing at this point, so like I said, initially I might just cross that exit, that horizontal asymptote. I probably want to check this -4, just one more point just to check out here. So if I do that, well, that's just slightly below, so that's -0.2. So this should be going like this, and then we go along this asymptote. This actually just slightly goes under, and it looks like it should be coming back and running along this way. So that will happen sometimes. We need a few more points over here between these asymptotes. So let's look at 1. So at 1, we get -0.67. so about 2/3. So roughly about here. Let's look at 2. 2, we get -1. So it looks like it's going like this. So you could probably guess at this point, it's just going down like this. Second, let's see if I can do this part a little smoother. Okay, I accidentally touched the line a little bit. Let me smooth that out just a little bit more. So this should be running along this asymptote, and this should be running along this asymptote. Sorry, my board, for some reason, it does that a little bit. Then we have this asymptote at 3, so let's look at a point at 4 and at 5, just to get a general idea of what's going on out here. So if I look at 4, I'm getting a value of 0.78 approximately, and at 5, I'm getting a value of 0.36. So that's right here, and then the 5 and 0.36 is about here. That's enough to kind of tell me that I probably I'm going to be, well, definitely we know here we're going to be running up like this, and this looks like it's probably going to run along that intercept. So that's roughly what that graph should look like. And just to show you, that is roughly what my graph looks like, just like that. So for you, try 9 and 10. So just kind of get some general graphs of the function. So we'll do this one, and then, like I said, these ones we'll do one by one, but these are a little quicker graphs to do. Okay, so for number 9, I need to bring that up on my little my other graph of this because we need these points here in a minute. So we need a vertical asymptote. So that is going to be where 2x minus 4 equals 0. And that is going to happen. Remember, it's the difference of squares. So we get x plus 2, x minus 2. That means my vertical asymptotes are going to be x equals -2 and 2. So let me do those in red again. Your horizontal asymptote, like I said, when we're looking at x, say, going towards infinity, what we should have here is that my leading terms should take over, and my leading terms are 2x squared on top and then x squared on bottom. Well, the x squareds cancel out. I'm left with 2, so y equals 2 would be my horizontal asymptote. Okay, so next we're just going to look for, like we did before, the intercepts. Give myself a little space here. If we already know we're graphing a function, so we'll get rid of that part. So our x-intercept is when the numerator is equal to 0. And so if we were to think of this, multiply this together, we get -10. I need factors of -10 that add up to +3. Well, that would be 5 and -2. So we can break up 3 as 5x minus 2x. So factoring by groups, I can see I can factor out an x, and I'm left with 2x plus 5. Here I can factor out a -1, and I'm left with positive 2x plus 5. I can factor out my 2x plus 5, and I'm just left with x minus 1. So my two intercepts would be, in just a minute here, we'll get them. We've got to solve this. One will be at -5/2, or what we'd say is negative 2.5. And then the other one is going to be at 1. So we'll have 1 here and 1 here. Get my points up here, so we'll have this here in a second. Because now we are going to find a couple, oh, sorry, we need our y-intercept, then I can find a couple points. Y-intercept means I just have to figure out what happens when x is 0. So I'd have 2 times 0 squared plus 3 times 0 minus 5 over 0 squared minus 4. So that's going to leave me with negative 5 over negative 4, which is positive 5 over 4, or approximately 1.25. So this is your horizontal asymptote. No, sorry, your horizontal asymptote. I was completely wrong. It is your y-intercept. Sorry, apparently I just don't know what I'm saying anymore, which is right here. So you just need to grab a couple points, figure out what the rest of this is going to be doing. So let's make our chart quickly. X, h of x. So looking right here, we already got an intercept here. Let's look for another point. So let's say we look for 1, 2, 3, negative 4. Negative 4, we get 1.25. So it's kind of giving me this general shape where I know it's going to do this. So just give me enough to kind of figure out what the curve should be doing, and I know it runs along the asymptotes. In the center between these two vertical asymptotes, I have 2 points. I might just need one more to kind of know, it's like, is this turning back down? Is this going to keep going up? So we're going to look here at negative 1. And negative 1 gives us 2. So we are going to be crossing that horizontal asymptote. But remember, we have to run along those vertical ones. So I'm confined to this little area here. Now we don't have any points out in this section, 1, 2, 3. So let's look at 3 and 4. 3 will give me a 4.4 and 4 will give me a 3.25. So here, 1, 2, 3, 4, about 4.4 would be here. And then we need another point at 3, 1, 2, 3, 3.25, so about there. And I'm expecting I'm running along these asymptotes. And that is exactly what the graph looks like. I have it up on my phone here. All right, so for these ones, sort of a little less work. So I'm going to make a little spot off here so we can get a little more room to work with this. Okay, so starting with A. Vertical asymptote, x plus 2 has to equal 0, meaning x would be equal to negative 2. Horizontal asymptote, as x goes towards infinity, my leading terms take over, which in this case is going to be x over x. This equals 1, so I have a horizontal asymptote at y equals 1. If I am looking for x-intercepts, I have to look at where the numerator is equal to 0, which is going to be at x equals 3. I also need a y-intercept. So that is when I am going to set x to 0. So I just need f of 0, which is going to be 0 minus 3 over 0 plus 2. So negative 3/2 or negative 1.5. So let's graph these features. Vertical asymptote would be here. Horizontal asymptote would be here. My x-intercept is here, and my y-intercept is here. So now I just need a couple points to kind of finish this out. So x, f of x. So maybe some points. I got these two here. I'm probably good. You may just want to look at, like, say, -1 to get one more point to know what's going on. So look at that one. Other points we may want to consider, it's like at least 2 or 3 points out here. So maybe -3 and -5. If it's not enough, we'll look at -4. So we just need what the function values would be at these points. Oops, just a second, so acting weird. Okay, so what we would have here is at -1, the function value is -4. At -3, the function value is 6. And at -5, the function value is 2.67 approximately. So we just graph these points, 1, 2, 3, 4. -3, 6. So this would be 5 here. So 6 would be about here. And then -5 and 1, 2, 2 and about 2/3. So we need to follow asymptotes, meaning one side is going to look like this. And the other side, I completely missed my points. The other side should look roughly something like this. Sorry, I'm having a hard time controlling this. All right, I guess that's good because I'm getting, we'll pretend we hit the point. So that is what A would look like. So I'm going to clear this out and then we're going to do B. All right, so for B, we're going to have our vertical asymptote would have to be wherever the denominator equals 0. So in this case, x squared minus 9 equals 0. Well, that means that x minus 3 times x plus 3 should equal 0 because it's the difference of squares. So my zeros would be at -3 and positive, or not, sorry, yeah, +3, -3 would be the zeros at the bottom. So those are my vertical asymptotes. Horizontal asymptotes, if we are sending x towards infinity, what we're going to see is that f of x should start acting like the leading terms. So that has to do with the power. So we'd have the negative x squared, and then the next largest power is the x squared on the bottom, or so the largest power on the top, on the bottom is x squared, and on the top is negative x squared. And that is going to be -1. So y equals -1 is my other asymptote. X-intercept. So the top is 8 minus x squared equals 0. So if we solve this, we can add the x squared over here. So 8 equals x squared, which means, I'm going to move it this way. What we have here is that my choices are x can be plus or minus the square root of 8. So that in itself isn't particularly helpful to us. So as an approximation, the square root of 8 is about 2.83. So I have 2 points that are going to be my intercepts. One is going to be at 1, 2, almost here, and the other one is almost here. And then we need our y-intercept. So that means we need to find f of 0, which is going to be 8 minus 0 squared over 0 squared minus 9. So we're going to have 8. Sorry, let's get a little bit of room there. I'm going to have 8 over 9, but 9 is negative, so it's negative 8 over 9. And this is approximately 0.89. So about negative 0.89. So approximately right here. So it looks like in the center here, I have enough to kind of tell me I'm going to get this bow shape. And then I have to follow those intercepts. Sorry, I accidentally crossed one. Let me try to do this side one more time. So I'm going to need a couple more points. So some good candidates for me. Kind of need to know what's going on this side of this asymptote. So let's say we pick 4, negative 4, and negative 5. Negative 4 is approximately 1.14, and negative 5 is approximately negative 0.06. So it's not a big difference. So maybe another point we'd want to look at is something even closer to the asymptote, like a negative 3.5. That's going to give me negative 1.31. It's maybe a little bit more helpful. So we got to be here at about 1 1/3. Then at 1, but like just under for the negative 1.14, and then we're just slightly under still. So we're seeing that we're getting a slight curve here. This will keep running along your intercept. And this will, or sorry, running along not your intercept. Your one side will run along your horizontal asymptote and one will run along your vertical asymptote. All right, it's a couple points for the other side. So learning from this side, we might want to look at a positive 3.5, 4, and 5. So this is going to be a negative 1.31 again, a negative 1.14 again, and a negative 1.06. So that is roughly here, then here, and then here. So roughly the same shape as the other side. All right, and that would be B. So one more to go. All right, so our last one, C, vertical asymptote. We have x plus 1 would have to equal 0, so it's at x equals negative 1. Horizontal asymptote, if x is going towards infinity, we would end up with f of x approaching a leading term of x on top, and the bottom is just a leading term of x. So we got y equals 1 is your horizontal asymptote. So asymptote here and asymptote here. Okay, so I will also need my, here we go, my x-intercept. So this one would be easy. Where is the numerator equal to 0? Well, there it is at 0. So it also tells me that, once again, this is also a y-intercept. Because if we look at f of 0, then we end up with 0 over 1, which is 0. So they just share that same point. Now, just to find a few additional points. So let's try on this side where we already have that point here at 0, 0. We could look at, let's go a little bit out. Let's say look at 2. So at 2, we're getting a function value of 0.67. So roughly here. So it looks like I'm probably just running along this asymptote. And I definitely can only run along this asymptote. We're seeing that we're curving towards going down. Oh, we need a few points on this side. So let's say, let's look at -2 and -4. -2 is 2. -4 is going to give me 1.33. So -2 is 2, like I said. And then we are here, and then we're just about here. But it's enough to give me that little idea of what that curve looks like. And there is A, B, and C.